Earth rhythms means what? Earth rhythm is not having proper rhythm. Where all we are using the cloud computing ranges from scientific, engineering, gaming and social networking. Cloud computing technology allows the remote monitoring of the patient heartbeat data. Why we have to go for prediction? To do different researches in the life science. Hello everyone, welcome to the one more session on cloud computing. Myself Vidhyaashram, Faculty of Computer Science Department, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Today in this model or in this unit, we are going to discuss about the cloud application where all we are using the cloud. To say we are not untouched with the cloud. Whatever we are doing on the daily basis, all connected to the cloud. So here in this particular chapter, we are going to discuss some of the major applications what has have a diverse effect on that particular area. Okay, let us start. Cloud application, huge popularity in industry due to its ability to host the application for which the services can be delivered to customer rapidly at the minimum cost. Why cloud is so popular? We are giving the services. What type of services? The services required by the user, any type of the services with the minimum cost. Okay, that's why it has a huge popularity. With discuss application case studies dealing their architecture and how they leverage is various cloud computing technologies. So in this chapter we are going to discuss that. The range of domain where all we are using the cloud computing ranges from scientific, engineering, gaming and social networking. So these are some of the major areas what we are going to discuss in today's session. Scientific appliances, why we have to use in scientific applications, increasingly using cloud computing system and technology in scientific area for many reasons, because data is available, readily available, services are readily available, you can process the large amount of data. These are all some of the advantage why we are using the cloud computing in the scientific application. High performance computing application, high throughput computing applications and then the incentive application. Why? The main thing what we have, why we are using the cloud computing in a scientific area is high performance and a high throughput. Let us see what is high performance and high throughput. High performance computing and high throughput computing. In high performance, in terms of resource availability, quality of service and monitoring of services. How we are measuring the performance? We are measuring the performance depending on the resource availability, quality of service what they are providing and then the monitoring of services, whether they are providing the proper services or not, monitoring those services. That comes under what? High performance. Then what you mean by high throughput computing? You ask for the thing and in the fraction of the second it will be on your table. That is nothing but high throughput. It means that users requesting to get a process within the span of time which is already decided by the cloud service provider. What you are asking, you are getting in fraction of second. That's why we call it as high throughput computing. Next, where we are using this cloud computing? In health sector. In the healthcare, for ECG analysis, cloud computing is used for ECG analysis. What is ECG? ECG, all of you know, for any heart related thing, if you want to know, it will be known by its beats, right? So that is finding the rhythm of the heart is called as ECG. The full form of ECG is a electrocardiogram. Okay, nowadays you have a EEG also. We are basically discussing only on ECG. ECG is the electrical activity of the heart cardium. Cardium means how does it beats. Due to this activity on the way from the produce as a scientific way for that the represented over the time and that represent the heartbeat. For that particular instant or that particular time, how heart is working, that will be represented. The analysis of the shape is used to identify the earth rhythms and it is the most common way of detecting the heart diseases. Earth rhythms means what? Earth rhythm is not having proper rhythm. If your heart is not beating at the proper rhythm, standard heartbeat will be 72 beats per minute, right? If it is exceeding that, majorly exceeding that, or minimum of that, then you can say there is a problem in heart is not beating properly, not in rhythm. So that is called as not having the steady rhythm. To find this, what they are doing? They are doing a ECG. This how it will be represented at this point in time, where our heart is beating here, here and here, here, like this. So this is a ECG diagrammatic representation output what you are getting from the ECG machine. How this is related to the cloud? Now ECG analysis in the cloud, how it is going to analyze whether the given graph is proper or not. Cloud computing technology allows the remote monitoring of the patient heartbeat data. It will monitor remotely, as you need not to go to the diagnostic center or you need not to go to the doctors to have the proper, to check whether your heart is working proper or not. It can manage the data by remotely. Remote monitoring can be done. Through this way, the patient address can be constantly monitored without going to the hospital for ECG analysis. It is connected with your device. Device is connected with the cloud. From wherever you are, directly you can monitor your heart rate. Thus, you can have what is the address, what is the thing to be addressed from the patient. At the same time, the doctor can instantly notify if the case has to be attended, whether no it is a proper, no it is a very serious thing, whatever it may be, the doctor is also get the notification regarding that. This is how the architecture has been built. Here this is a user is connected with the different sensors, ECG sensor modules, Bluetooth connectivity. Then here we have a cloud. In this cloud, user will be accessing these resources. Here we have a different layer of service provider, PaaS and SaaS. ECG data analysis as a service. Here what we are doing? We are analyzing a data. Here what we are doing? Dynamically scalable runtime security we are providing as a PaaS. How these cloud and the sensors are connected? These are connected with the wireless network. Now not is a 3G, now it's a 5G. From 5G or 4G, you can connect with the mobile net, cloud, and then the mobile network you can connect. Let's have a detailed discussion on that. In this figure, there are different types of computing devices equipped with the ECG sensors to constantly monitor the patient heartbeat. So, equipped with the different sensor to monitor the heartbeat. Then, the respective information is transmitted into the patient's mobile device that will immediately forward it to the cloud hosted web services. That is immediately transferred to the cloud hosted service devices. Then the entire web service forms the front end of the platform that is completely hosted on the cloud, that consists of 3 layers, that is SaaS, PaaS and IaaS. All the 3 layers will participate in the cloud hosted applications. Okay, next what we have is advantage of using cloud in healthcare. In this concept, the cloud computing introduces an opportunity that would be otherwise hardly achievable. By using the cloud, you can achieve the thing very fastly. The first advantage is elasticity of the cloud infrastructure that can minimize and maximize according to the request served. First advantage what we have, we can minimize or maximize according to the use. The second advantage, that cloud computing technology are known because easily accessible, and also it permits us to deliver the service within the minimum time. In the span of time, it will deliver the services. As the results, doctor has no need to invest in the large computing infrastructure. You need not to have a large ECG machines. Either of that, you can ask the patient or the user to install the app and make use of that. Next, what are the example we have in the scientific field is protein structure prediction. In protein structure prediction, what's going to happen? Protein structure prediction are the chain of amino acids joined together by prepared bonds. How it is joined? Together with bonds. Mini conformation of this chain opposite due to the rotation of the chain about each atom. That protein chain like this you will be having, right? So each atom will rotate here. It will rotate among itself. So that is a mini conformation of this chain opposites due to the rotation of the chain due to about each atom. The protein structure is thus conformed. The protein structure is that conformed changes that are responsible for the difference in the three-dimensional structure of the protein. You can make out the difference by looking at these structures. What is a good protein, what is a bad protein, depending on that they can make a decisions. Why we are using the cloud computing in the protein structure prediction? Why we have to go for protein structure prediction? Because it requires high computing capabilities. When we are putting this protein structure in the 3D format, it need more computability. Often operates on the large data set. We are not operating on the small organization or small data set. To predict anything, you should need a large data set. So, because of high computing and large data set causes the expensive operations, IO operation. So, we are using the cloud computing here. And the protein structure prediction is a computability incentive task that is fundamental to different type of resources in the life science. Why we have to go for prediction? To do different researches in the life science. Once we know which is good, which is bad, we can decompose those proteins to form something new, which is something good. So, these are all comes under life sciences. Benefits of having protein structure prediction. Manually 3D structure dimension is difficult, slow and expensive. So, by using this cloud computing, you can do it more efficiently. Structure helps in designing the new drug for the treatment of diseases. Why we are going to predict that? Because to design the new drug. For example, recently we have gone with a pandemic called COVID. How we have decoded that, we find the antivirus for that, and that all you know. That is known case by using some life science applications with the help of cloud computing. So, this is a structure, protein prediction structure. Web portal enables a scientist not to worry about the predicting task. Scientists need not to worry about the predicting task. Scientists need to give only the data to the application. Prediction will be done by cloud. The work is done by cloud service provider. What they are doing here, they can we have a three phases: initial, classification and final phase. Initial one we have given. This initial phase has been divided into B, C, D, E, F, G and H. After this, it will be combined together and giving one prediction, that is I. A is a blast. B is create the data vector. Here you are separating the data using vector. And here C is a HSC classifier. Some different types of protein will be classified into different classifiers. Then after combining this, you can predict something out of it. That is, here they have given the explanation of the diagram. Machine divides the pattern recognition problem in three phases. That is initialization phase, classification phase and final phase. These phases execute in parallel to reduce the computation time of the prediction. We are not using queue implementation, we are using parallel. Together they are going to work. The prediction algorithm is then translated into task graph that is submitted to Aneka. Once the task is completed, the middleware makes the result available for virtual through the portal. One task is completed, then this Aneka will make it available on the web portal. Okay. Next, we'll move on to gene expression data analysis. Genes means DNAs. In small terms, we can say DNAs. Gene expression data analysis. That particular example what they have taken here is cancer. What is cancer? Cancer is growth of unwanted cell within the body that causes some diseases. Cancer is a disease characterized by the uncontrolled cell growth and profiling. This behavior, of course, because genes regulate the cell growth and mutation. This means that all the cancerous cells contain a mutated gene. Whatever the gene we have within us, that will be mutated. Mutated means taking some other forms which our body does not support. Then it causes cancer. This is all about how cancer will happens. This uncontrolled growth develop the different types of tumors. In this context, gene expresses profiling. This utilizes to provide a more accurate classification of the tumor. Here we can classify the tumor depends on the context of the gene which is not present in the body. The dimensity of the typical gene expression data set ranges from several thousands to 10 of the 1000 genes. It is not easy to have a genes to categorize the genes. You will be having several thousand, not one. Thousands to 10,000 million, billion, trillions genes you will be having in your body. To segregate, we need help of cloud computing. For these, large classification is solved by extended classification user system, that is XCS, which has been successfully utilized for classification of large data set. To classify these cells which is grown unwantedly or uncontrolledly grown, we are using the XCS to classify the large data set. Gene expression data analysis that can be done using cloud XCS, that is a machine learning classification system for the gene expression data set on the cloud infrastructure. It extends the XCS model by introducing the co-evaluatory approach. Co-evaluatory approach we are using, that's why it is all coex. Okay. The coex divides the inter-search space into served and minds and employs the standard algorithm in each of these subdomain. What it will do? It will divide the complete problem or complete data set into small data set. Then it will work on that by applying the algorithm such as to the subdomain. Then we can find out the problem or the base problem. Next, we move on to the geoscience. Satellites image processing. How this can be used in the geoscience. Satellite image includes the photograph on the earth taken through an artificial satellite revolving around the earth. The process of correlating these satellite images for haze, cloud and sensors includes the defect within the satellite images. So all of you know how satellite image will be taken. Some artificial satellite will take the picture and then that has to be processed. All the picture taken by the artificial satellite will not be useful for us. We have to segregate those images so that we can use it for the community or we can use it for the geoscience for any applications. Then how does it process? Process satellite images have a different scientific and need based application where all we can use in the field of architecture, we can use this in the field of geology, of the history, biodiversity, conservation and regional planning. These all are where we can use this satellite images. In satellite images, this type of application collects procedure analysis, huge amount of data, because all images cannot be usable, but simply satellite will click the pictures and it will store somewhere. So it will be having large amount of data. By developing the sensors and the satellite for monitoring the technology, our planet will become more instrumented. We cannot put all the sensors in the satellite. It will be more instrumented. Due to the development of Geographical Information System, GIS is a major implementation in the field of geographical science. Cloud is come into picture. Whenever we have this problem, the solution is cloud computing. GIS, that is Geographical Information System application, can process all type of geographical reference data, a large data, and it will process that large data. It picks only the data which is proper and which is useful. This information is useful for the civil security purposes. Not only in the civil security purposes, it will be useful in many other fields also. Okay, then the cloud computing is an advancement of this kind of application, generating the meaningful results. The satellite image sensing generates a lot of raw images that need to be processed further. That raw image, who is going to process? Cloud is going to process. This requires high computation in both the input and output manner. Taking the input in the large amount, giving the input in the large amount. In the both, it will need high computation. We have already discussed what is high computation, high performance and high throughput. Right? Large size images can be transferred into the local ground station to cloud computing facilities for further solution and correctness. Whatever the data taken by the satellite, that will be transferred to the ground station where we have a cloud computing. Using that facility, further the solution, whichever the data, proper image that should be kept, whichever the image that is related to geoscience will be kept separate, that is related to civil services, that will be kept separate. Like that, it will segregate the data. The cloud computing will provide an accurate infrastructure for these kind of services. Okay. This is what the image of geo satellite. Here we have a local drive. It will take the pictures, it will send it to the local drive. From the local storage, using cloud computing, we are achieving. Here we have Aneka platform. From Aneka platform, it can be given to the private cloud or it can be given to the public cloud, depends on the request or depends on the need of the applications. Then it will be given into, achieved into the SaaS, that is a software as a architecture. Whenever needed, we can access this. Okay. The following figure states that the different types of technology are integrated in either computing environment, because we are including all type of services there. The SaaS services contains a collection of services for geocode generation and data virtualization. The SaaS what we are using, it is used for what? Geoscience collection and then the data virtualization. Aneka controls the sending and receiving of data in the infrastructure. This Aneka controls what? Receiving and sending of data from infrastructure. And processing of these images, processing task produce a desired outcome from the raw satellite images. The public and the private cloud will be provided the resource on demand. Why we are using public or private cloud depends on the data, whether it is a public data to be put or private data to be put, but it has to provide on demand resources, required resources to process that particular data. Then business and customer application, we are using mainly nowadays, they are using CRM and ERP software in the business and consumer application. Nowadays, CRM and ERP are main software that has been used for the business and consumer applications. Consumer relationship management and entrepreneurs resource planning applications are the market segment that are flourishing in the cloud in current situation. Access to the business and then the customer data from anywhere and from any device. It provides what? Accessing the data, customer data from anywhere and any device. ERP system, entrepreneur relationship programming system, integrates several aspects of enterprises, finance and accounting with the human resource manufacturing, supply chain management or project management and CRM. All these things put in together forms the ERP. What all these things? That is entrepreneur, finance, accounting, human resource in need for particular industry, manufacturing, what should be we manufactured, supply chain, how much we have manufactured, how much has been on demand, Depending on the demand, we should manufacture. And management project, how to manage the complete setup. And also CRM, customer relationship model, that is for this particular industry we have particular customer, targeting on that customer and providing the relation between the customers, that all will be put in one software, that is called as ERP. ERP solution are less popular than a CRM solution at this time, because it is, since it is combining all, this will be more costlier compared to customer relationship management. So this is all about business and customer relationship. Here it is also been used, cloud has been used to improve the productivity. These are some of the cloud application that has been used to improve the productivity in business and customer relationship. Apart from business and customer relationship, we have social networking. In the social networking also the cloud has been used. I need not to explain the Facebook much, because each and everyone will be using the Facebook as a social networking. Media applications nowadays, all OTT forms, news channels or all the media applications. Video encoded on the cloud like your Skype, Google Meet, everything. Video encoding on the cloud. Multiplayer online gaming, as you are doing the most popular one, PUBG or any other. I don't know much. You know it better than me about online gaming and social media networking, right? So these are all some of the applications used by the cloud computing, with the help of cloud computing. That's all for the cloud applications. Thank you.